Lesson 29 is all about solving literal equations. Now, the term literal is defined right here in our new concepts page where it says a literal equation is the equation with more than one variable. That's it. That's our basic definition. It has more than one variable. So if you recall, when we're solving an equation with a variable, you want to get that variable by itself. So here you've got 2x minus 6 equals 4. You're going to use inverse operations to isolate that variable as shown below. So it says minus 6, they added 6. What you do to one side, you do to both sides. That eliminates the 6 on this side. Now you have 2x equals 20 because you added those up. You would divide by 2 because 2 times x is your operation. You do the inverse or opposite of that. Dividing by 2 is going to give you x by itself. In a literal equation, you've got more than one variable. But as in an equation with one variable, you do the same thing. You use inverse operations and properties of equality. So you do the opposite operation, and what you do to one side, you do to the other side in order to solve for one of the specific variables. The solution for the specific variable will be in terms of the other variables and numbers. So you basically are taking one of the variables, solving for that variable to get it by itself so that it's in the form of x equals or y equals, and then the other side of the equation can actually have that other variable in it. In example 1, it says solve for a variable. You've got the equation 2x plus 3y equals 10. It says solve for y. Anytime it says solve for, that's the variable that you're trying to get by itself. So you're trying to eliminate everything else by doing the inverse operation. Let's just see how they looked at that. So you've got 2x plus 3y equals 10. You're trying to get y by itself. That means you got to get rid of the 2x and the 3. Here first you're going to subtract 2x because it's adding 2x. So you've got an inverse operation here. What you do to one side, you do to the other side, your property of equality. And now negative 2x and 10 or minus 2x and 10, those two things don't go together because they're not like terms. So you actually write those out in the form of a full equation. And you're always going to put that variable first. So it says minus 2x plus 10. Now, Mr. Shane, why does it say plus 10? Well, 10 was positive, so you can keep that positive sign right here. In this case, then you've got 3y equals negative 2x plus 10 because those didn't go together, and you still have to get rid of this 3. You would divide by this 3 on this side, and that means divide by 3 on the other side. When you're dividing by something on one side of the equation, it's actually divided by all the parts of the equation over here, even though there are two terms in this expression. So the 3 goes underneath each of these variables, and then you write it out in this simplified form. Y equals negative 2/3 x plus 10/3. The variables being solved for is on both sides of the equation. The first step is to eliminate the variable on one side or the other. So you've got to get rid of the x in this case and then solve for just the y on this side of the equation. Example 2 says solve for variables on both sides. In the equation here it says solve for p when you've got 4p plus 2a minus 5 equals 6a plus p. Justify each step. Now they want to get, in this case with variables on both sides, the same variable on the same side to add those terms and then separate them afterwards. So here it says eliminate the p on the right side by doing the opposite operation. So you've got plus p over here, they subtract p. What you do to one side, you do to the other. So it's 4p minus 1. You would get 3p plus 2a minus 5 equals 6a. So now you have the expression in this portion right here with variables on both sides. You want to get rid of everything besides the p on this side. So positive 2a, you would do the opposite, minus 2a. Negative 5, the opposite, plus 5. And you do that to the other side. Now you can only combine like terms where they are similar. 6a minus 2a plus 5 gets you to 6 minus 2 is 4a plus 5. You got 3p equals 4a plus 5. Divide by 3. Again, you're going to divide by each term, and here's what your simplified expression looks like. Again, inverse operations and properties of equality to get that variable all by itself. The formula is a type of a literal equation. Use inverse operations to isolate any variable in the formula. For example, this connects us to science class in example 3. The formula C equals 5/9 F minus 32 is the expression for Celsius temperature in terms of Fahrenheit. So how do you convert Celsius to Fahrenheit? Because we know that those degree terms aren't exactly the same. So in this case it says find the Fahrenheit temperature when the Celsius temperature is 20 degrees. So we want to find what Fahrenheit is, but we have to find the equation for Fahrenheit. In this case, we're given the equation for Celsius. So C equals 5/9 F minus 32. To flip that, you got to solve for F. That means get F by itself. Here you've got inside the parentheses the subtraction, and you've got 5/9 on the outside. You're actually going to do the opposite and then multiply to get rid of that, that fraction. The opposite of multiplying a fraction is to multiply by that reciprocal. So here you have, instead of 5/9, you would multiply by 9/5. These would cancel on this right side. You do it to the other side. You got c times 9/5. And then you rewrite that with them being right next to each other. Now you still have f minus 32 here. The opposite would be plus 32, and now you have your new equation. F equals 9/5 c plus 32. Now it says, what is this? Find the Fahrenheit temperature when the Celsius temperature is 20 degrees. Well, you take that 20 and you plug it in for the C right here, and then you just simply substitute and solve that. So 9/5 times 20 is 36, plus 32 is 68 degrees. So if it's 20 degrees Celsius out, it's 68 degrees Fahrenheit. So you can see how you can do that conversion with both of these equations. This equation is important to remember for finding Fahrenheit. This equation is important to remember for finding Celsius. If you know both of those equations, you don't have to worry about this math to change back and forth, but that's a good way to practice what we're learning right now in terms of solving with inverse operations. In example 4, it applies this in the form of our geometry question. The formula for the circumference of a circle is c equals 2 times pi times r. The circle's circumference is 24 inches. What is the radius? Leave the symbol pi in the answer. So in this solution, since the question is asked for the radius, the first step is to solve for r. That means get r all by itself. So you rewrite the equation by solving for that specific variable. That means you got to get rid of the things that are on that same side. Here you've got c and 2 pi. Well, how do you get rid of 2 pi if they're next to each other? That means multiplication. The opposite or inverse operation is to divide. You divide, and now you've got the rewritten equation right here. Now you can substitute the 24 inches for your circumference and then solve for the radius. 24 divided by 2 is 12. You get 12 over pi as your radius. Another example would be in the form of making travel plans. The Ramirez family is taking a trip to the coast. They live 270 miles from the coast. They want to make the trip in 4.5 hours. Use the distance formula, d equals rt, to determine the average speed the family needs to drive. So in this case, they give us some information and they want us to solve for another portion of the information. They want the trip to take 4.5 hours, and we know that it's 270 miles. So we know the time and we know the distance. We don't know r, which is the rate of speed. It's asking us, they want what is the average rate of speed that the family needs to drive. So the answer will be the speed they are driving, so solve for the formula for r. d equals rt. How do you get r by itself? You divide by t on both sides, and now you have a new equation, rt. Plug in what you know. D is 270. T is 4.5. 270 divided by 4.5 is going to give you 60. They need to drive 60 miles per hour in order to make their goal of how they're traveling. That makes sense, just because that's close to what the speed limit would be. Now, in our lesson practice problems, you're asked to solve for a specific number of variables and apply these that went with each example. For example, in the first one, you're going to solve for n. That means 3n plus 2n equals 8. And I'm just going to write this out and describe this to you, so you'll have to maybe listen to this back again or replay it if you're going to be following along and writing this out. You've got 3n plus 2n equals 8. You're going to solve for n. That means get n all by itself. So the first thing you're going to do is think opposite operations. You've got a positive 3m. So I'm going to subtract 3m from the left side. What I do to the left side, I'll do to the right side. I'll subtract 3m from that side as well. It'll cancel out on the left-hand side, and on the right-hand side, I can't combine the 3 and the 8. So my new expression looks like this. 2n equals negative 3m plus 8. Remember, the 8 stays positive because it's a positive number, and the negative 3m can't combine with anything, so I have a new expression written out. Now I have 2n equals negative 3m plus 8. I have to solve for n. 2 times n would then mean I need to divide by 2 on both sides. Divide by 2 on the left side is going to separate and get n all by itself. On the right-hand side, the 2 is divided by both of those terms. So I would get negative 3 halves m plus 8 divided by 2 is 4. So again, my final answer is n equals negative 3 halves m plus 4. For letter B, it says solve for x. In this case, you have 3x plus 2y equals 8 plus x. You have x actually on both sides of the expression. This comes back to example 2, which means you need to get the variable that you're solving for on the same side first, and then eliminate everything by using your opposite or inverse operations. So because I have 3x on the left side and 1x on the right side, I want to get rid of that 1x because it's smaller. So it says plus x, I would minus x. What I do to one side, I do to the other. And now I'm going to have 3x minus 1x to give me 2x. Now I have a rewritten expression, 2x plus 2y equals 8. To get x by itself, I need to get rid of the 2y and the 2. So I would subtract 2y from the left side and subtract 2y from the right side. My new expression looks like this. 2x equals negative 2y plus 8. And again, now I would divide by 2. Divide by 2, that divides both of those terms on the right-hand side, and I would get a final answer of x equals negative 2 divided by 2 is going to give me negative 1. Negative 1y plus 8 divided by 2 is 4. Here's my final answer. X equals negative 1y plus 4. For letter C, it asks you to convert the formula again. The temperature for Fahrenheit equals 9/5 Celsius plus 32 expresses the Fahrenheit temperature in terms of Celsius. Find the Celsius temperature when the Fahrenheit temperature is 86 degrees. I would use the formula that we just learned in the previous example and just simply plug in that overall number. So to convert Fahrenheit to Celsius, you're going to go back up to this example, and you're going to use this equation right here to find the Celsius degrees. If it gives you 86 degrees in Fahrenheit, plug that value in right here. You would do 86 minus 32 times 5/9, and you'd probably find that to be an answer of 30 degrees Celsius. Letter D, the formula for the volume of a rectangular prism with length L, width W, and height H is V equals LWH, or length times width times height. Find the height in inches of a rectangular prism with a volume of 6 feet cubed, width of 12 inches, and a length of 24 inches. In this case, you're going to rewrite the expression and solve for h, which means you have to divide by length and width. So here you would divide by these two, and your new expression would look like this. H equals volume divided by length times width, and now you can plug in the variables that you know in order to solve for those. So you know that the volume is 6 feet, so that's going to be in your numerator. You know that your length and your width, which are in inches, 12 inches is going to be 1 foot and 24 inches is going to be 2, so you're going to multiply those by 2 or turn those into inches as well. You would have, in that case, 1 divided by 2, or 6 divided by 1 times 2, which is 2, so 6 divided by 2 is going to be 3 feet. If you change that into inches, 3 feet is equal to 36 inches. For letter E, the traveling cost. The fuel economy rate of a vehicle is determined by the formula F equals M divided by G. And the formula F is fuel economy, M is miles traveled, and G is gallons of fuel. Felicia's car has a fuel rating of 28 miles per gallon. Her trip is 350 miles. How many gallons of fuel does she need? So you've got your expression, F equals M divided by G. We're asking to find or solve for G. So we would rewrite the expression by solving for G. In this case, G is in the denominator, so you're going to have to actually divide by the value or multiply by the reciprocal value, in this case, of M. If you're going to multiply by M on one side, that's going to flip that equation, and your new expression is actually going to be in terms of G. G equals M divided by F. Now you plug in what you know and solve for the number of gallons. So the miles she traveled is 350. That goes in the numerator. 350 is going to be divided by her fuel rate, which is 28 miles per gallon. So 350 divided by 28, you're going to figure that out to be 12.5 gallons. Now, hope that helps in terms of how to solve these problems. If you need to, look back at our example problems to say, how do you actually do this inverse operation? Solving a literal equation is all about using the opposites and that property of equality. Solve for the variable that they're asking. That means get that variable all by itself. If you have questions, feel free to reach out. Take care of those practice problems in your assignment today. God's blessings.